MCQ 19 is a speed of reaction question, so let's investigate the profile. The original profile here sees us using X with a volume of 100 cm3 and a concentration of 1 mole per dm3, and for Y, similarly at 100 cm3 and a concentration of 1 mole per dm3. Now, it was mentioned in the first statement that 1 mole of X will react with 1 mole of Y to produce a gas, telling us that the mole ratio is exactly 1:1. Now, a little bit of an investigation here with respect to height of a reaction, which is indicative of the U of a reaction, is dependent on the number of mole of limiting reagent that is actually available. Now, when it comes towards determining the gradient of a reaction, which is otherwise indicative of the speed of a reaction, we will be taking precedence from the limiting reagent as well as that from the excess reagent. So for the case of using solutions, the gradient could have been affected by the concentration of the reactant itself. So for the case for X, we're going at 1 mole per dm3. For Y is 1 mole per dm3. And they mentioned that this produced the line R. So I'll say that R itself comes on with the stiffness attributed to 1 mole per dm3 of X, as well as 1 mole per dm3 of Y. Now, calculating the number of mole here for X and Y, we get as 100 over 1000 multiplied by the concentration of 1 will give us the mole of 0.1 mole for X. Similarly for Y, it will be 0.1 mole. So the height that we're obtaining here is due to the production of 0.1 mole of X reacting with 0.1 mole of Y. Now the same experiment is repeated again, however there's a little bit of an alteration, and this resulted in the obtaining of line U. Now line U, indicative over here, is still have the same height, telling us that the number of mole of X and Y should still stick to 0.1 mole for each of them. However, the apparent greater in stiffness could have suggested to us that we are dealing with a much higher concentration, because the higher the concentration, this increases the frequency of effective collision between reactants, and ultimately this increases the rate of reaction. So looking through at A, B, C, and D, we need to fill up the number of moles for X and Y to make sure that they are falling into the 0.1 mole each category so that it can attain the same height. Now for A itself, after taking the volume to multiply by the concentration for X, we are going to get the value of 0.05 mole. For Y, 100 over 1000 times 1, it gives us a mole of 0.1. I will have to say no to this question because X is not fitting at 0.1 mole. For the case of B, we do get 0.1 mole for X as well as 0.1 mole for Y. This still seems plausible. For the case of C, we also get 0.1 mole for X, 0.1 mole for Y, and lastly for the case of D, we get 0.2 for X and 0.2 for Y, which means that this is not plausible. So we are left with both B and C, and the elimination should come from something that actually has a lower concentration than 1 mole per dm3 for X and Y, because we're looking for something that's higher to achieve a much greater stiffness. So for the case of C, you see 1 mole per dm3 for X, we are relying on a higher concentration for Y, however it disappointed us with 0.5, and with that we will have to eliminate C from the answer. But for the case of B, you see a 1 mole for X as well as a 2 mole for Y, and this increase in the concentration of Y leads to a higher frequency of effective collision, and therefore B should have been the correct answer for this question over here.